Welcome to Chapter 7. This section is on finding areas of rectangles, parallelograms, and triangles. An area hopefully you are very familiar with, so let's get started. An area is the number of square units needed to cover a region, like a floor, the floor in your bedroom. How many little square pieces of carpet or square tiles you would need to cover that floor would be the area, and it is in units. So in this case, units matters. Is it in square feet, which is 1 foot by 1 foot, square inches, square yards? Makes a big difference in your final answer, so be careful of that and know that every region has an area. Every region has an area. Let's start with the simplest, the most basic. This is the one everything else is built upon, and that is the area of a square. So the area of a square, since by definition all the sides are the same, you multiply the side times itself, side times side, to figure out how many square units you would need to cover it. By the way, you could count squares, overlay it over a grid and count how many squares cover the floor. But you don't want to do that, not if you can just multiply. So the formula for the area of a square is the length of the side multiplied by itself, or the side squared. By the way, that's why we call to the power of 2 squared, because you're making a square out of it, like x squared. Instead of x to the power of 2, we're making a square, x times x. That's just where that, just for your information. If I have 2 regions that are next to each other and without overlapping, then to find the area of the whole thing, I would find the area of each section and then add them together. So the area of this square plus the area of that square would equal the whole thing. If regions are congruent, their areas are also congruent. Just makes sense. So here's a square, which is 40 times 40. That's 1600. This next to it is also 1600. So to find the total area, I would add those together. So the total area would be 3200 square units. To find the area of a rectangle, you multiply the base times the height. So the base times the height, or just length times width, is another way that it is described, but that's all you have to do to find the area of a rectangle. The formula for the area of a parallelogram is exactly the same as a rectangle. In fact, a parallelogram is just kind of a tweaked rectangle, isn't it? A rectangle leaning to its side, you can think of it. It's still base times height. The thing you have to be really careful of with parallelogram is that you have the right height. This side right here would not be the height of your parallelogram. It needs to be the perpendicular distance from the base to the top. So I can find it here, or I can find it here, but not here. Be really careful with that. Okay, here's an example of a parallelogram. I notice I have this side is 25 and this side is 13. So this parallelogram has dimensions 25 and 13, but its height is not 13. Its height is this 10 inches. So what you need to multiply in order to find this area is the 25 times the 10. Be really careful. So this area would be 250 square inches. That leads us to the triangle. The triangle, I kind of outlined a little bit so that you could see a triangle, any triangle, is always half of a parallelogram. If you take a parallelogram, cut it in half, you're gonna get a triangle. So the area of a triangle fits the area of a parallelogram. If a parallelogram is base times height, and a triangle is half of that, well, its area is 1/2 base times height. Same thing, you need the perpendicular height of your triangle and to its corresponding base, multiply those, divide in half. That is your formula for the area of a triangle. Okay, and I have a triangle on a coordinate plane and I'm asked to find the area. So I need a base and I need a height. And if I can do this horizontally or vertically, it will be so much easier. So what I'm gonna do is I'm gonna make this side here my base. And then I'm going to connect that to here for my height. That will be a lot easier. So this base then would be from -6 up to 5. It would have a length of 11. And if I'm not confident, all I have to do is go 5 minus -6, the difference of those two numbers. But if I need to count squares, you can count squares. My base has a length of 11. Now to count height, I can count from -4 to 2, my x's, that would be 6. So my height is 6. If you need to count squares, you can, but the difference between my x's would be here, -4 to 2 is 6 units. So my area is 1/2 times 11 times 6. And that is 33 square units. So the area of this triangle is 33 square units. I have a triangle drawn on the board. It has a base of 12 feet. I do not know its height, but some very nice person told me that its area is 54 square feet. How tall is my triangle? What is the height of my triangle? How do I find a missing dimension? So use your formula for the area of a triangle. An area of a triangle is 1/2 base times height. And then plug into that formula the numbers that you know. I know the area is 54. I know my base is 12. And all I need to do is find my height. So 1/2 of 12 is 6. So that means 54 is equal to 6 times the height. Divide by 6, and I find out that 54 divided by 6 is 9. So my height is 9 feet. Here is a very rough sketch of a back of a house. And let's say we need to put siding on this house, and we need to purchase all that siding. How much area needs to be covered with siding, and how much will it cost us? So first we need to figure out the area needed to be covered with siding. We have a rectangular portion here, we have a triangular portion here, and we have 4 windows that we're going to pretend are the same size. So we're going to take the area of the rectangle plus the area of the triangle and subtract out the 4 windows to get our total area. These dimensions are in feet. So our rectangle would be 27 times 12. Plus our triangle, it looks like there's not a base here, but it's the same as this. So the triangle would be 1/2 of 27 times 8. So there's the triangular portion, but we need to subtract from that our 4 windows. And the windows have dimensions of 3 by 4. So we're going to subtract from this 4 3 by 4s. So we're going to simplify all that with our calculators. Multiply this, multiply that, add these together, subtract that. That will give us our total area. So taking one section at a time, the rectangle has an area of 324 square feet. The triangular portion up top has 108 square feet. The windows save us 48 square feet of siding. So when I add that all together, that gives me my total area, which is 384 square feet. Okay, I go to the store. I know how much I need to buy, how much I need to cover my house. The contractor sells it to me for $650 for each 100 square feet. What's my total cost going to be? So I take my square footage and I multiply it by 650 for every 100 square foot, and it looks like this. So I multiply straight across. My square feet units cross cancel. I'm left with the dollar amount, and it simplifies to be almost $2,500, $2,496 to be exact. That's how much it costs to put siding on just the back of this house. Okay, let's work through a few practice problems. Here's a parallelogram. What is the area of this parallelogram? Figure it out. Pause if you have to, but I doubt you'll need to. Hopefully you see it's base times height, 12 times 4, not 12 times 5. So it's 48. And don't forget, 48 is just a number. Since this is an area, I need the units. And it's the units to the power of 2, squared units. So this is 48 square meters. If you are given a problem like this and you're asked to find the area of this figure, there's a couple different ways you can go about it. One way is to break it up into smaller sections, to find the area of each one of the smaller sections and add them together and to get your answer that way. The other is to pretend like this kind of door cutout isn't even there. Find the area of the entire thing as if it was solid. Then find the area of this rectangle and just subtract it out. So you can do the whole minus this rectangle, or you can divvy this up into sections and find them individually. You pick which way you want to do it. Find the area of this figure, pause if you need to, come back and see how you did. Okay, I'll show you how I went about it. I did the entire figure by going 10 times 9. Base times height, and got 90. Then I said, okay, what is the area of this rectangle? It's 7 meters high, but how wide is it? Well, if this whole thing is 10, and this is 5, and this is 2, then I subtracted that 7 from 10 to realize that this has to be 3. So 7 times 3 gave me the area of that rectangle that I subtracted out. 90 minus 21 left me with 69 square meters. That was the correct answer. Hope you did well. Okay, one last problem to challenge you. Here's another one to find the total area for this figure. You can either find each individual section, add them up, find the whole thing, subtract these out, whichever method you want to try. Go for it. Come back. We'll see how you did. Again, I took the approach of finding the entire figure and then subtracting out these cutouts. The entire figure is 11 by 12, so I multiplied 11 times 12. The dimensions of this portion here are 4 times 7, and the dimensions of this little section here is 4, and then this is 3. And I found that out because this whole side is 11 and this is 4 and 4. So 11 minus 8 left me 3 here. So I have my 11 times 12, which is the whole thing, that's 132. I subtracted 4 times 7, which is 28. And then I also subtracted this section, which is 3 times 4, which is 12. So 132 minus 28 minus 12 comes to 92. Notice there were no units on this problem, and so you're thinking, okay, how do I do that? So I just used U for units. I've also seen it UN for units. Either way, just a U or a UN squared. So this is 92 square units, whatever they are. I hope you found this review of finding areas pretty helpful. I will see you guys next time where we'll move on to other quadrilaterals. So bye for now.